Hello Pre-Calc students, today we start Unit 5 and today we are talking about non-right triangles. So basically all the rest of the triangles, the ones that don't have a right angle. If you don't have a right angle, you cannot use SOHCAHTOA. SOHCAHTOA, oops, try again. SOHCAHTOA is only for right triangles. So triangles that have a right angle. So if you have any other kind of triangle, you need other rules. We're going to learn about two of them in this unit, the law of sines and the law of cosines. The law of sines is the most straightforward. You can kind of peek ahead and see how simple it is. But let's see when you would use the law of sines. You would use the law of sines if your triangle is not a right triangle. We can also call that an oblique triangle. If you're given two angles in one side, which could be angle, angle, side, or it could be angle, side, angle. And then also you can use the law of sines when you're given two sides and the angle that's opposite of one of those two sides. So that would be side, side, angle. Remember in geometry class that your geometry teachers told you that you could not use side, side, angle to prove two triangles congruent because it was not one unique case. And that's what's going to make the side, side, angle case just a little bit more complicated than angle, angle, side, or angle, side, angle. So to use the law of sines, you need to know that you'll have a triangle like this one here, ABC, and opposite of angle A is side A, opposite of angle B is side B, and opposite of angle C is side C, so that you can say that side A divided by the sine of angle A is equal to side B over the sine of angle B. And usually you just use two of these ratios, so you could use the A's and the B's, or you could use the B's and the C's, or you could use the A's and the C's, and you'll see in the examples how you would choose which ones to use. Let's look at example 1 and see if we can apply the law of sines to find all the missing information. It tells us that angle B is 20 degrees and angle C is 31 degrees. And then it tells us that side B is 210 centimeters. So you can see I have both pieces of information about B. I have angle B and I have side B, so I definitely need to use that one. So I'm going to do B over sine B. Now the other piece of information I have is angle C, so I can use angle C to find side C. So I'm going to do equals C over sine C. Alright, so now we'll put some numbers in. Side B is 210 centimeters and sine 20 degrees. Side C is 30, oh no, we don't know side C. And then sine of C, so sine of 31 degrees. So we need to solve this for C. So you're going to multiply both sides by sine 31. So I'm going to do times sine 31 on both sides. That doesn't look good at all. Let's try again. Okay, so I have C divided by sine 31 times sine 31, so those cancel. And C equals all of this. So let's see how would I enter that in the calculator. It would be C equals 210 times sine 31 divided by sine 20. Alright, and let's pull up the calculator and try that. Let's see. I need to press mode and make sure I'm in degree mode. So I'm in degree mode right now, but if you're not, fix that. And we're going to press 210 sine 31. Close the parentheses. Divided by sine 20. And close the parentheses. Okay, so I get that side C is 316.23. And I think for today we're going to round to the hundredth place for our final answers. So I get C equals 316.23, and then don't forget your unit, in this case centimeters. Okay, so I have this one. Alright, I don't have either information about A, but if you remember, in any triangle the angles add up to 180. So if I subtract 180 minus 20 minus 31, I should get angle A is 129 degrees. And now I have enough information to find side A. In order to have as little error as possible, it's best to go back to your original information instead of using the information you just found. So I'm still going to do B over sine B. And let's change color again. So I have B over sine B equals A over sine A. And side B is still 210 centimeters, and that would be over the sine of 20. Side A is what I don't know, and that's going to be over the sine of 129. So you're going to cross multiply to solve for A, or you could just multiply both sides by sine 129. So if I multiply both sides by sine 129, I'm going to get something similar to what I got over here. And let's see if I can find enough space to write it. A equals 210 sine 129 divided by sine 20. Okay, so let's type that in and find out what side A is. (210) sine 129 divided by sine 20. Alright, so then I get that side A is 477.17. 477.17 and centimeters. Okay, so I think we accomplished our goal. We found all of the sides, we found all of the angles. Okay, let's take a look at example 2. In example 2, they tell us angle A is 115 degrees, C is 28 degrees, and B is 50 meters. So you'll notice that we don't have any corresponding sides and angles. So what we'll do is we'll subtract from 180 to find angle B to start. So B is going to be 180 minus 115 minus 28 degrees. And we get 37 degrees. And so now we still need to find side A and side C. So the matching information we have is for, let's see, this is supposed to be 50 meters right here. So we have side B and we have angle B. So we're going to need to use that. We're going to do B over sine B equals, and you have your choice if you want to find A or if you want to find C. So I'm going to find A over sine A. So side B is 50, and divided by the sine of 37. Side A we don't know, and that would be over the sine of 115. 15. So now if I multiply both sides by sine 115, sine 115, sine 115, I get the A by itself. So what you're going to type into your calculator would be A equals 50 times sine 115 divided by sine 37. Okay, 50 sine 115 divided by sine 37. And we get 75.30 meters. Alright, so now we have to find side C. So we're going to go back to our original information about B. We're going to do B over sine B equals C over sine C. And we're going to still have 50 over sine 37. Equals C, I'm trying to find C, divided by the sine of 28. So then, if you multiply both sides by sine 28, you get C equals 50 sine 28 divided by sine 37. And let's type that in. 50 sine 28 divided by sine 37. And we get 39.00 meters. Okay, and we've solved our triangle in example 2. Okay, let's go back to those application problems. Some of these application problems can be tricky for drawing the picture, so what you may want to do is draw the picture with or without the help of the video, but then pause the video to see if you can apply the law of sines to solve the problem. So the golfer misses a 12-foot putt by putting 3 degrees off course. So the golfer, let's see, try again. The golfer might start somewhere around here, and the hole might be like here. But he actually hits 3 degrees off course, so he doesn't actually hit it directly to the hole. That would have been the straight path. This is your 3 degrees in here. And so let's see. It was supposed to be a 12-foot putt, so that would be from the start to the hole, 12 feet. But he went 3 degrees off, and now the hole lies at a 129-degree angle between the ball and the spot before the putt. So if the ball is now over here, that's your ball, then this is 129 degrees. So we have 2 angles and we have a side, and we want to find what distance does the golfer need to putt in order to make the shot. So this is our x over here. So we don't have to solve the whole problem, we just need to find that x. Now in order to find that x, we first need to find this angle in here so that we have a corresponding angle and opposite side. So we're going to do, for the ball, the angle of the ball is going to be 180 minus 3 minus 129. And we're going to get 48 degrees right here. 48 degrees. So then I can do 12 over sine 48. And I'm trying to find x, and opposite of the x is the 3 degrees, so x over sine 3. Okay, so then you want to multiply both sides by sine 3. So over here and over here. And those will cancel, and you're going to get x equals 12 sine 3 divided by sine 48. And let's just type that in to see what you get. 12 sine 3, close parentheses, divided by sine 48. Alright, and you get 0.85 feet. So it was actually pretty close. Even though you shot 3 degrees off, the ball was pretty close to the hole, only less than a foot away. So hopefully you have a pretty good chance still of making that second shot. Alright, architecture. An architect's client wants to build a home based on the architect Sheets Goldstein house. The length of the patio will be 60 feet. So let's see, where's that 60 feet going to be? That's going to be this part here on the bottom. So we have 60 feet here. And then you have these two sloping roofs. So it says the left side of the roof will be a 49-degree angle. So over here, 49 degrees. And the right side will be an 18-degree angle of elevation. So over here, you have 18 degrees. Determine the lengths of the left and right sides of the roof and the angle at which they meet. So if we want to call this the left side of the roof, strangely, I'm going to have to call this angle L. And if I want to call this the right side of the roof, then I would call this angle R. So the angles don't seem to match up with left and right, but that's okay. So now I have no information that's complete, so I need to subtract from 180 to find that angle up at the top. So if I do 180 minus 49 minus 18, I'm going to get that this angle up top is 113 degrees, right here. And then I can set up the law of sines. I can say 60 over sine 113 is equal to, let's do the left side. The left side we don't know, but we know the angle L is 18, so sine 18 degrees. And then multiply both sides by sine 18. And these cancel. So L equals 60 times sine 18 divided by sine 113. Okay, and when you type that in, you should get about 20.1 feet. And then you need to do the same thing for the other side. So this time I have 60 over sine 113 equals the right side over sine 49. And multiply both sides by sine 49, and you should get that the right side equals 60 sine 49 divided by sine 113. And when you type that in, that you should get the right side is about 49.2 feet. Alright, these travel problems are an interesting set of problems. You'll probably see another one of these. Alright, for the initial 90 miles of a flight, the pilot heads 8 degrees off course in order to avoid a storm. So let's see. we have a start, and we have an end, and this would be your direct path. Oops. If I move my end over, that would be a direct path. Alright, but you actually go 8 degrees off course because you're trying to avoid a storm. So let's go like that, and there's your 8 degrees in here. And that's the first 90 miles of the flight. And then the pilot changes direction to head towards the destination and makes an angle of 157 degrees. So this angle here is 157 degrees. And we need to find the total distance of the flight. So if I'm going to use the capital S here for start, I could make this a lowercase s here. So in order to do that, I'm going to subtract from 180 to find my missing angle in here. So my missing angle is 180 minus 157 and minus 8. And I think we get 15 degrees. Let's double check. Yeah, 15 degrees. So this is 15 degrees right here. And then we can set up our law of sines because we can say 90 over sine 15. So 90, let's see where I have space, over sine 15 equals, and we're trying to find s, so I have s over sine 8. Oh, so then you're going to multiply both sides by sine 8. And those cancel out, and so you can say s equals 90 sine 8 divided by sine 15. Alright, and when you type that in your calculator, you should get that s is 48.4. And miles is our unit. But we want to know the total distance of the flight. So the total distance of the flight would be the 90 that we did already plus the 48.4. So 90 plus 48.4 equals 138.4 miles for our total distance. Now we want to find the distance of the direct flight. So the direct flight is over here, and we can use a different variable for that one. Let's just use a lowercase d for a distance. So now we're trying to do, and notice we're still working on problem 3. So we're trying to find d, and you can set that over the sine of 157. And let's use your original information if you can. So that would be 90 miles over the sine of 15. And then when you multiply by sine of 15 on both sides, nope, you multiply by the sine of 157 on both sides, you're going to get d equals 90 sine 157 divided by sine 15. And if you type that, you should get that your distance is about 135.9 miles. Okay, and our last application problem is about a ski lift. So the ski lift rises at a 28-degree angle during the first 20 feet up a mountain to achieve a height of 25 feet, which is the height maintained for the remainder of the ride up the mountain. Determine the length of cable needed for this initial rise. So what are we trying to find here? We're using this triangle on top, so if we isolate that, that could help us a little bit. And we might also just want to put some letters in. Let's see, trying to erase that. Okay, so let's call this A and B and C. So we know that this part here is 20 feet. And we know this part here is 25 feet, and we know this angle is 28 degrees. So we're trying to find the length of the cable, which will be this part up here, x. So we can set up a law of sines because we have an angle and its opposite side, and this problem looks a little different from the ones we did previously. So we could say 25 over the sine of 28 is going to be our missing side x. No, we can't do x yet because we don't have angle C. But we could find this angle here, angle B. So we could say this is equal to 20 over the sine of B. Alright, so this time our variable's in the denominator, which is more tricky. Of course, these ratios are going to be equal even if you flip them upside down, so you could always do that as well. I'm going to cross multiply in this case. So if I cross multiply, I have 25 times sine B equals 20 times sine 28. And then to isolate sine B, you divide by 25. So you have sine B equals 20 sine 28 divided by 25. And then if you wanted to find angle B, you could do an inverse sine. So B is equal to the inverse sine of 20 sine 28 divided by 25. Now I know it's tempting to do part of this at a time and then insert answers back in, but the problem is on your calculator, once you start rounding, you're going to get to some significant rounding errors. So it's best to isolate the B and then just type all of this at once. So let's try that. We need an inverse sine of 20 sine 28, close those parentheses, divided by 25, and close parentheses again. Okay, and we get 22.06 degrees. So B equals 22.06 degrees. And let's look at that up here. Okay. Alright, so then to find angle C, we're going to subtract from 180. So C equals 180 minus 28 minus 22.06 degrees. 180 minus 28 minus 22.06. So C equals 129.94. Okay. It's 129.94 degrees. So now we're trying to find the length of this cable here. So we'll have x over sine 129.94 equals, and we can do 25 over sine 28. So multiply both sides by sine 28. And these will cancel. Oh, that doesn't work because we're trying to isolate the x. Let's try again. Let's multiply by sine 129.94. And now these will cancel. So we're going to put into the calculator x equals 25 sine 129.94 divided by sine 28. So 25 sine 129.94 divided by sine 28. So we get about 40.83. feet. Okay, so this last problem is a little bit different because we were given two sides and an angle instead of two angles and a side. And this is a case of side-side angle, which is when law of sines gets a little bit more complicated. Because it turns out if you're given side-side angle, it is very possible that there is more than one triangle, or that the information given actually doesn't describe any triangles. So on the next page, we're going to get a quick introduction to the ambiguous case, and we're going to go more in detail with ambiguous case in the next video. Alright, so if you're asked to solve an oblique triangle and you're given the side, and the angle, then there are three possible outcomes. You could have no triangles at all. You could have one triangle, or you could have two triangles. So if they give you an angle that is obtuse, that is greater than 90 degrees, then your choices are only 0 triangles or 1 triangle. But if the given angle is less than 90 degrees, that's when you could have all three cases. 0, 1, or 2 triangles. So down here we're going to start trying to get an idea of when we're actually talking about the ambiguous case. In the first example, let's just look at a triangle that's ABC so that we can try to figure this out. So if I just label this angle A, this angle B, and this C, that would make this side A, and side B, and side C. So if I'm given little a, little b, and big C, little a, little b, and big C, then this is a side, angle, side. Now we haven't had any examples of side, angle, side yet in our law of sines notes because it turns out law of sines actually is not useful in solving this kind of triangle. But we do know from geometry class that if you're given side, angle, side, that there's only one possible triangle. Alright, in B we're given side A, side B, and angle B. So we're given this side, and this angle. So that would be a case of side, side, angle. So in that case, it's kind of hard to tell how many triangles we're going to have. And we will learn a few rules that will help us. But let's see if we can draw a more accurate picture to figure this out. We have... So if we have our angle B down here, that's 45 degrees. And our angle A is here. We don't know what that is, but we do know that side A over here is 3. And then we know the side opposite of B is 5. Well, it turns out that 5 can meet up in this one way. We're going to see other examples where if this 5 were a smaller number, it's possible we could make 2 triangles, but in this case we're just going to make 1 triangle. Okay, part C, we're given angle A and side A and C. So let's see how that would look. So let's put our angle right here, A, and it's going to be 100, which is of course more than 90 degrees, so there's 100. And then here's my angle C over here, which means that my side C would be 2 right here. Now if I made a side of 3 over here, it looks like it might not actually reach over here to make a triangle, but it might. And so the way we can find out is actually just by trying to solve this with the law of sines. So if I solve this with the law of sines, I would have 3 over sine 100 equals 2 over sine C. And then I multiply, cross multiply both sides so that I have 3 sine C equals 2 sine 100, and divide by 3, so I get sine C equals 2 sine 100 over 3. and then you apply an inverse sign to find C. So C would be the inverse sign of 2 sine 100 divided by 3. So it turns out that this is possible because we get for angle C, we get an angle of 41 degrees, which tells us that there is a triangle that would work here. If there was not a triangle, we would get an error at this point. Alright, in D we're given side, side, side. So in geometry class you learned that side, side, side would form just one triangle. But this one happens to be a tricky one because if you think that your side C is down here, this is the 10, and your A is over here, this is the 3, and your B is over here, this is the 4, well, you can see the 3 and the 4 are never going to meet if this side is 10. So there is a simple rule from geometry that says the two smaller sides have to add up to more than the third side, or these sides will just never meet up and make a triangle. So this is actually a case of 0 triangles. And then in part E, we are given 2 angles and the side between them, which is angle side angle. And angle side angle from geometry class we learned proves just one triangle. So this diagram down here is supposed to explain a little bit about how the ambiguous case works. When you are given an acute angle, you could have any of these cases here. So if you're given an acute angle and you're given sides A and side B, if side A is less than the height right here, you can see how that side A would dangle and would never actually reach the bottom, and this is how you would have no triangles. If, however, this A were exactly the same as the height of the triangle, you would actually have one right triangle from that situation. And then another way you could have one triangle, although not a right triangle, is if you are given angle A and you're given side B, but A is bigger than B. If A is bigger than B, it's not going to dangle. It's going to form one triangle over here. And then a tricky case is when you're given angle A and you're given side B, but this last side here, A, is a value that's between the height and the side B. You could actually form two different triangles. Here's one of them, right here. And then let's change color to look at the other one. It still has the same angle A, it still has the same side B, and this length over here is still A, but look how it forms an entirely different triangle. So you have the blue triangle and you have the green triangle, and they both have the same information, the given angle, given side, and given side, but that information can be used to form the two different triangles. Okay, then if you're given an obtuse angle, there are really only two cases. Here's your angle, here's your given side, and here's your other given side, and if this one's too short to reach down, you'll have no triangles. But if it's long enough to reach, then you can have one triangle. So let's look at this example here, which we're going to use. We're going to find two different triangles because it's going to be this case right here where the given information can describe two triangles. So it says draw two triangles with the following measures, solve the acute triangle using law of sines, and next find the B in the second triangle by subtracting. The B from the obtuse triangle is equal to the 180 minus B in the acute triangle, then solve the obtuse triangle. So in our acute triangle we have A is 60 degrees. Try again. So here's A, and they tell us B is 10, and then over here we'll have B. And so then we have C up here, and this could be 9 over here. Or I could have the same information. Actually, let me see if I can copy that. Okay. So there's my A again, and here's my C, and here's my 10. And this one, we're not sure how long it is, but this time the 9 comes in like this, forming an obtuse angle from angle B right here. Okay, and we have 60 degrees here, and this one's also 60 degrees. So you solve the first triangle the same way we've been doing law of sines. Nothing has changed. So I'm going to find angle B next. I have 10 over sine B equals 9 over sine 60. And I'm going to get 9 sine B equals 10 sine 60. And divide by 9. And then do an inverse sine. Okay, so you're going to type that all in the calculator, and you're going to get that B is about 74.2 degrees. So we'll put that here, 74.2 degrees. And then to find angle C, you can subtract from 180. So we have C equals 180 minus 60 minus 74.2 degrees, so we get 7.45 degrees. Is that right? No. We get 45.8 degrees. So let's add that up here, 45.8 degrees. So then we have to find side C, so we're going to do side C over 45.8 degrees is equal to 9 over sine 60. And we're going to multiply both sides by, sine 45.8, and you get C equals 9 sine 45.8 divided by sine 60. And you're going to get that C is about 7.45, and we don't have a unit on there. So 7.45. Okay, so then we need to find this other triangle. So in this case, it is because we were given side B that we're going to find angle B next. And our new B is going to be 180 minus our old B, and our old B was 74.2. So I get my new B is 105.8. And then to find my new C, because this triangle adds up to 180, it's going to be 180 minus 60 minus 105.8, and I get that my new C is 14.2 degrees. So there's only one more thing to find in my second triangle, and that's side C. So you can do C over sine 14.2 equals 10 over sine 105.8. And when you cross multiply and solve, you should get C equals 2.55. And that's the last piece of our second triangle. So then there are some classwork problems that you should try, and you can check those answers with the PDF.